Hi, this session is on the elimination method, but part 2. So these equations will look a little bit different. So the questions that we'll be doing, we have to use the elimination method, not the substitution method. You can use either one for any equations that are given to you to find the solution, but sometimes questions are specific. And if it says use the elimination method, then we have to use that. Now, if you have a look at these two equations, with part 1, we had to locate two coefficients that were the same. If we have a look at the x coefficients, we have a 1 here and a 2 there, and they are different numbers. And here, remember, forget about negatives and positives for now. Here we have for the y coefficient 5, and down here it's 3. They are two different numbers as well. So there is no way I can get 5 and 3 to equal 0, or can I get 1 and 2 to equal 0? It's impossible. So we have to actually make a change to one of these equations. And before we do that, I'll show you what I mean. We'll just go to another page. Now, if I just write a random equation, just say 2x equals 6. Nice and simple. We can solve this without any working out. 2 times a number to give me 6. Well, I know that 2 times 3 is 6. So if I solve this, the answer would be x is equal to 3, or just divide by 2. Now, I'm going to just do a little test. If I, for example, let's say, multiply this whole equation, so I'll put brackets around it, and I'm going to multiply the whole thing. I'll pick any number. I'll multiply it by 4. Okay? So what I'm saying is I'm going to multiply this side by 4, the 2x, and also this side here. So I'll end up with 8x equals 6 times 4 is 24. Okay, so I've just multiplied both sides by 4. Now, if I solve it, am I still going to get x equals 3? Let's have a look. So if I divide by 8 to solve for x, divide by 8, x will equal 24 divided by 8 is 3. I still got the same answer. So the whole point of this is if you multiply both sides by a factor, in this case 4, you have not actually changed your equation. You will still get the same answer when you solve it. And it links to fractions. For example, if I have a half as a fraction, okay, and we know that with fractions, what you do to the bottom, you must do to the top. So if I times the bottom by 3 and the top by 3, I'll end up with 1 times 3 is 3 over 2 times 3 is 6. I know that 3 over 6 is still what? If I put in my calculator, I will still get 0.5 or a half. So 3 over 6 is still a half. It's the same value or same amount as a half that's simplified. They're both equal fractions. It's just that in a real life context, if it was, for example, looking at pizzas, we've got more pieces of pizza in this case compared to this one here. We've got 1 out of 2 or 3 out of 6. But they are still equivalent fractions because they equal, when simplified, a half. And the same sort of thing applies. What you do to one side, you must do to the other, okay? And that will ensure your equations are equivalent. So this equation here is equivalent to this equation over here, 8x equals 24, just like fractions, okay? So keep that in mind. So using what we have just learnt, we have to change either equation 1 or equation 2 to make one of the coefficients the same. And it's up to you what you pick. You can work with the x coefficients. So here I have a 1 and a 2, and here I have a 5 and a 3. It doesn't matter which one you pick, but try and pick one that will, I guess, involve less working out. And I can see that the coefficients of x, 1 and 2, are easy to make the same. Okay, so I'm going to make 1 and 2 the same. To do that, I have to multiply the 1 by 2. And if you're not sure what I mean, if I put this as my denominators, just say I've got a fraction, just say I have, I'll do it down here, I'll clear this page. Just say I have, so one denominator is a half plus, I'll just say 2 over 1, just say. All right, to add these two fractions, we know we have to have the same denominator. To make them the same, I can simply go 1 times 2 and must do the same thing to the top. So I end up with a half plus 4 over 2. And I can add them now. To 1 plus 4 is just 5 over 2. And I end up with an improper fraction. But the whole point is to make them have the same denominators, you either change your small number to the bigger number. And if that's not possible, then you've got to change both. But with our example here, I can turn my 1 into a 2. Now, to do this, we have to make sure we multiply everything else in the equation by, in this case, we'll multiply it by 2. So I'll write some working out to explain what I'm doing. I'm getting equation 1 and multiplying equation 1 by the number 2. So all of equation 1 by 2. I'm going to write what I have down here. So I can put brackets up here. Actually, no, I'll do it separately so we can see the question. So I've got x minus 5y equals negative 17. And I'm going to multiply all of this by 2. And let's see what we get. I'll use a different colour. So we've got 2 times x is 2x. Negative 5y times 2 is minus 10y equals, and minus 17 times 2 is negative 34. Okay? And I now have what you can say a third equation, because I've changed one equation to a different thing. So that's my third equation. So just to make sure you're following, all I've done is, with my first equation, I have changed it to this equation down here, and they are equivalent. It's like equivalent fractions. They are the same thing. If we solve them, if it was possible, we would get the same thing, okay? The reason why I changed it is I wanted to make this coefficient of 1, that was in front of the x, I changed it to a 2. And now the whole point is, you can see, if I write equation 2 underneath, so I've got equation 3 and equation 2, I've got 2x now plus 3y equals 5. I can now eliminate my x's because they're both the same. 2 and 2 we can get 0. So I'll start it on a new page just so we have more room. So now I've got my new equation, which is equation 3, and I've put equation 2 underneath it. And now I'm going to work out to eliminate the x's. Do I add or subtract? So now we just do the exact same thing as we did in part 1 of elimination. In this case, we are eliminating the x. So I'm going to say, just to show some working out, I'll get equation 3, take away equation 2. And let's see, the reason why I said take away is we should have done a test first. I've got a positive 2 and a positive 2. I want them to equal 0. That means, pretty straightforward, I've got to subtract them. 2 take away 2 is 0. So I am subtracting equation 2 from equation 3. So 2x take away 2x is just 0x, which I don't have to write because it's eliminated. Now, this is where you've got to be careful. Minus 10y minus, or take away, a positive 3 equals negative 13y. So I've got negative 13y equals, now once again, minus 34, do a test. So minus 34 minus a positive 5, okay? This will equal minus 39. Just be careful with your negatives. And now all I've got to do here is solve this equation. So divide by negative 13. Cancels out. Divide by negative 13. And don't be scared of odd numbers. Just put it in your calculator and you should get a positive 3. Because 13 times 3 is 39. And we have found the y value of our solution. So we haven't found x yet, but we have found the y value. So we still have to find x, and we know this part by heart now. All we've got to do is substitute y equals 3 into either equation 1 or 2. So always go back to the original equations, okay? 1 or 2. You technically can use equation 3 because it is equivalent, but in case you made a mistake when changing it, it's best to go to either what you started off with. So I'll look at, I might use equation 1 and to find my x value. So now there's my equation 1. So I'm going to substitute when y equals 3. So I will have x minus 5 times 3 equals negative 17. Minus 5 times 3 is negative 15 equals negative 17. Our next step is opposite of minus 15, plus 15, and plus 15. So x will equal minus 17 plus 15, that is negative 2. and I found it. So our final step is, therefore, the solution is when x is -2 and y is +3. And that is where those two lines cross over and meet at that one point. And there it is. With our next example, we've got 6x plus 5y equals 3. That's our first equation. I'll just number them now. And our second equation, we've got 5x plus 4y equals 2. And we have to use the elimination method. So the question is saying, find the solution using the elimination method. Now, if I have a look at the x's, I've got 6 and a 5. Now, I can see that I can't turn my 5 into a 6, so I have to change both the 5 and 6. Let's check my y. I've got 5 and 4. Unfortunately, I can't change my 4 into a 5 easily. So with this question here, we actually have to change both equations, okay? So we'll end up with another two more equations, so 4 equations. And if you're not sure what I mean, I'm going to do the y's just so we can do something different. You can do your x's if you want to, but I'll do my y's just so we can solve for x first. Now, if I have 5 and 4, just go to another page quickly, as my denominators, just to have 1 over 5 plus 2 over, I'll put 3 over 4. And to add these, we know we have to have the same denominators, so I can't turn my 4 into a 5, so I'll just multiply them with each other. That should give me the lowest common multiple or denominator. If you can think of something lower, then do that. But I'll just do this for now because I'm in a hurry. Times by 4. Okay, so I end up with my common denominator being 20. I've made the bottom numbers the same, and I've got 4 plus 15, and then I keep going. Okay, so we're going to be getting the same result for our equation. Our two equations. Because I'm focusing on the y's, to make them the same, I'll just times this whole equation by 5 and this whole equation by 4. Now, working out for these ones can get very messy. That's why just do it one step at a time. So I'm starting with equation 1, and I'm going to times equation 1 by the number 4. So now I'm going to write equation 1 out again. So I've got 6x plus 5y equals 3, okay? And I'm going to times this whole equation by 4. And let's see what we get. So I've got 6x times 4, that's 24x, plus, we know we should get 20y, because 5 times 4 is 20, equals, don't forget the 3, 3 times 4 is 12. Okay, so we know that this equation down here is equivalent to equation 1, it's the same thing. When we solve it, we get the same answer. All right, now I'm also going to change equation 2. So I can say this is my third equation that I've made, okay? And now my next step is, so that was my first step, is to get equation 2, so this one here, and times it by, to make 4 into a 20, I've got to times it by 5. So I'm going to write the equation out again. So I've got 5x, I'll just squeeze it here, 5x plus 4y equals 2, and I'm multiplying the whole thing by 5 to get a fourth equation. So I'll just do it down here. I should be able to squeeze it in. 5x times 5 is 25x. Whoop. Plus, it'll be positive 4y times 5 is 20y equals 2 times 5 is 10. Okay, and that is my fourth equation. Okay, so now I'll be working with the two equations that I've changed, equation 3 and equation 4, which is just down here, just squished in. So I'll start a new page with those two equations. Okay, so I've now put the equation 3 and equation 4 together, and I can see now I can eliminate my y's because they both have a coefficient of 20. And we know we really haven't changed the equations. We haven't made any new equations. They are equivalent to the other ones. And the other thing I forgot to mention is whenever you multiply by a number, never ever multiply by negatives, okay? Forget about negatives and positives. All you have to worry about in this first step is to make sure you make the numbers the same. We take care of our negatives at this point here, okay? Because otherwise it gets confusing. All right, so to eliminate my 20 and 20, they're both positive, but I'll still do my little test. So I've got 20 and then positive 20. I want them to equal 0. So to do that, I have to subtract them. Nice and easy. So I will be subtracting. You can subtract, so we'll go 3, whoop, take away equation 4, okay? And see what we get. So we're going to be subtracting these equations. So 24x take away 25. So I'll write it down here. 24 take away, it's a positive 25 equals, that will give me a negative 1. Just be careful with negatives, okay? So here I'll have, so far I have a minus 1x, or just x. The 1 can be invisible. Now 20 take away 20, we know the y's will be eliminated, so we can have plus 0y, but we don't have to write that. So the y is gone. So negative x equals 12 take away 10. So 12, positive 12 take away a positive 10 equals a positive 2. So we've got 2. And, oh, change my colour. Now be very careful, we haven't solved the x yet. That negative has to go on the other side. So divide by negative 1 if you want to, or do the shortcut way. Divide by negative 1. So x will equal 2 divided by negative 1 is negative 2. And we have found the x value of our solution, of our point. So x is negative 2, but we still have to find the y value, okay? So you can see how this is basically the hardest question you can get, because it involves a lot of working out, and just do it step by step. I don't mind how much space you take up. The more space you take up, the better. If you just rush everything, you'll make a mistake. And now this is the part that we always go back to. We've got to substitute this into either equation 1 or equation 2 that we started off with, and that will give us the y value. So let's do that. So our final step, we're going to sub in when x is equal to negative 2 into equation 1. There's my equation 1 to find the y value. So if x is negative 2, we have 6 times negative 2 plus 5y equals 3. 6 times negative 2 is negative 12 plus 5y equals 3. Next step is the 12. So I've got a plus 12 on this side, plus 12 on that side. So I have 5y equals 3 plus 12 is 15. And our final step, divide by 5, and y will equal 3. And we've done it. Okay? And please don't stop there. Your final thing is to write your final statement. Ready? So therefore, the solution is, and I want you to write it as a point, okay? Because when you get to year 10, that's what you'll be doing. The x value was negative 2. And we just found the y value. The y value is positive 3, just to make sure. And we've done it. So those two lines cross over when x is negative 2 and y is positive 3. And remember, we haven't learnt this yet, but remember each equation, okay? So these equations here, if we go back to the start, these, if we draw them on a graph, which we'll be learning soon, they give you a straight line, okay? And that's where those two lines cross over. So that's got its own line, that's got its own line, and we just found where they meet and cross over. So keep practicing elimination, especially these kind of questions, because they are trickier and they do involve a lot of working out. So please make sure you find a way to structure your working out nice and clearly so I can see exactly what you're doing. Thank you.